Okay, welcome back to solving systems of linear equation by the typical graph. Previously, we looked at identifying solutions for systems. That is, if we're given an ordered pair of some value, and we were to look at this particular ordered pair and see by substitution if it was true for both equations in this case, and if so, then it would be a solution to a system. Now we want to actually take a look at literally graphing these, on a coordinate plane, graphing these particular systems and see where they meet. So just some information you need to know: that all solutions of a linear equations are on this graph. And to find a solution of a system of linear equation, you need a point that each line has in common. So in other words, you would have to look for their point of intersection. Now, something that you need to keep in the back of your mind as we go through these too quickly is that sometimes it is very difficult to determine exactly where the lines cross when you solve our graphing. So it's going to be a rule. Let's just say we will create a rule saying that we will check our answer by substitution into both equations. So let's just get right to it quickly. We see in this example we have y is equal to a negative 2x minus 1, and y is equal to x plus 5 as our system. So what we do is, let's first of all take our first go ahead and take our first line, which is in this case y is equal to a negative 2x minus 1. We'll start with the negative 1, the y-intercept here, plot it, and then you notice the slope is a negative 2, so that's our rise over run will be a negative 2 over 1. So we're going to go down 1, 2 over 1, and then just simply connect our lines. Okay, so our second equation gives us the line y is equal to x plus 5. Okay, so in this particular we see that the y-intercept is 5, so we're going to go up 1, 2, 3, 4, 5, and then we notice that that's a 1 in front of our variable here, and so we will go actually up 1 over 1 to take our second point, and then just connect our line. So we will look here at this particular midpoint here and come up with the conclusion that it is negative 2 and 3. Okay, so again, because of the complication, and because we don't have graph paper here, but because of the complication, the graph just may or may not be correct. Let's go ahead and check it by substituting a negative 2 for x and 3 for y into both our equations to see if it comes out true. And here we have y is equal to a negative 2x minus 1. We'll substitute 3 for y. 3 is equal to a negative 2 times a negative 2, which is x minus 1. Negative times a negative is going to give us a positive, and 2 times 2 is going to give us 4. So this would be 3 is equal to 4 minus 1, and of course 3 is equal to 3. So the first equation checks out. So let's go to y is equal to x plus 5 and substitute 3 for y and negative 2 for x plus 5, and of course, yes, 3 is equal to 3. So that is indeed the correct solution for this particular system or equation, even though it's pretty difficult to tell here with the graph, but that would be the correct solution. And the second set system is we're looking at y is equal to 1/3 x minus 3, and then 2x plus y is equal to 4. Now notice one thing: the first equation is in slope intercept form. The second one is in linear standard form. So in order for us to work to graph these, we must transform both of them actually into slope intercept form. So the only thing we need to do is work with 2x plus y is equal to 4. And again, we've done this, so it's not anything complicated. We should know by now that in order to do this, we're solving for y, and or y equal, that's what we've said in class, and we're just literally bringing 2x over on the side with the constant 4. So in order to do that, we subtract 2x from both sides because 2x is a positive over here, and that's going to give us y left on the left side is equal to a negative 2x plus 4. Okay, so now we have them both in slope intercept form, and we can go from here with our graph. So we'll take the first one, and it gives us a negative 3. So let's just go ahead and graph this first one. So here's our negative 3. So this is our first equation over here, which is y is equal to 1/3 x minus 3. This is this equation here, and of course we use first negative 3, and then we went up 1 over 3. Okay, now this one is literally this equation, which is 2x plus y is equal to 4. And the way we did it, we took it in slope intercept form, and of course 4 would be our first point, and then again we're going down 1, 2 over 1 for our second point, and connect our lines. And as we can see, it looks as if it's giving us 3, negative 2 as our point of intersection. So let's check it, starting with the very first equation, substituting 3 for x, that's going to end negative 2 for y, that's going to give us a negative 2 is equal to 1/3 times 3 minus 3, and that's going to give us a negative 2 is equal to 1 minus 3, and negative 2 is equal to a negative 2. So far so good. Let's go on and take a look at the very second one, and here we have 2x plus y is equal to 4, substituting 3 for x, and that's 2 times 3 plus a negative 2, which is y, is equal to 4, and 6 plus a negative 2 is equal to 4, and indeed 4 is equal to 4. Now while I have you here, I want you to understand something that we can do, and we won't have a visual on this, but we can do this via our TI 84. So if you don't mind, if you have your TI 84, just go ahead and turn it on for me. And remember, we always do second plus sign 712 to make sure it's cleared. Go back to our Y editor, and let's just go ahead and pick the very first one, and let's just put in our Y editor 2. Well, actually that's a negative 2x, okay, minus 1. Okay, hit enter, and then go on and put in x plus 5 and hit enter. Okay, so from there we can take a look at our graph, and this is the very first problem that we've done. So we take a look at our graph and we see where our lines are. Well, now here's one concept I want to show you. The TI will tell us what our point of intersection is from the graph. So all we have to do from here is hit second trace. Okay, then you'll come up to the page that says calculate and value 0, minimum, maximum, and then the fifth one says intersect. So you hit 5, and then you come up with a screen that talks about the first curve on the bottom. Just hit enter there. Second curve, hit enter there, and then it'll say guess. We're going to use these a little bit later, but not at this point. Hit enter there, and then you will see intersection, and indeed it tells you that our intersection is x is a -2 and y is 3. So again, please guys, practice with these TI-84s as we go through this this lesson on systems, because it will be greatly helpful. I mean, this is going to be the best thing you ever done when you really, if you really understand this equipment when you're dealing with your end of course exam in May. Okay, so that takes care of graphing. And again, like we said, we want to make sure that we confirm this and not just take the graph, because it's difficult. It's very difficult to determine whether we have the right coordinates via the graph. See you next time.